Okay, so we're going to talk about multiplicity. It's basically how many times the root counts. For example, if I cross the x-axis, it's a linear, so it counts once. If I bounce on the x-axis, it's a quadratic, it counts twice. And if it looks like a snake, it actually counts 3 times. So it's my multiplicity for each root. Here I have 2 examples, one with an equation, one with a graph. For my equation, I have 3 roots. It's already factored, so I can set each one of them equal to 0 and solve for x. For this one, it'll be x plus 3. Solve for x, I get -3. For this one, x minus 1 is equal to 0. Add 1, so I get x equals 1. So I have 3 roots. So for this graph, it will have 3 roots, 1 at x equals 0, at x equals -3, and at x equals 1. To tell what type of multiplicity it has, I look at my exponents. For the first one, my exponent is 2. That means at that point, at that part of the graph, my graph will have a bounce, so maybe something like this. For my next one, it's to the power of 1. I don't have an exponent, so it's just 1 as my exponent right here. So that means the multiplicity is 1. So at x equals -3, the graph kind of just crosses it like that. So it has just 1. And then for the last one, it's the same thing. And if I add all my multiplicities up, I have 2, 1, 1 for a grand total of 4. So that means my degree is more than likely 4 because I have 4 roots. For the graph down here, let's say, for example, the one on the left is a negative. So we can say it's maybe -5, -1, and +2. So we can say that at x equals -5, because it crosses, but it has a curve to it, it's the multiplicity of 3. At x equals -1, it bounces, so it's a multiplicity of 2. And at x equals 2, I just cross, so it's a multiplicity of 1 for a grand total of 6. So it's an even function, which makes sense because my arrows are both going down. So that means this is an even function, but it's negative. So we can almost write the equation for it. For example, if you notice, if my root is negative, the factor is positive. So all I did was basically change the sign. So if this is -5, I can write it as x plus 5. And then -1 would be x plus 1. And then +2 would be x minus 2. And then for my multiplicity, exponent is 3, exponent is 2, and then exponent is 1. But because my graph is going down, I would have to add a negative in front so that I have a negative leading coefficient. And if I want to be more specific with my leading coefficient, I would have to know a different point on the graph. For example, if the graph would go through -2, 1, and using decimals or whatever, I can plug in different values for my leading coefficients like -1, -2, -5 to see what would make my graph go through that point. It's kind of like a guess and check game until you find something that works.